Hi guys, Peter Van Oost here again for our third practical test in Don Ruba's ETE 130 Digital Circuits class. We had the lucky draw of getting a fun circuit this time, like every time, but this one was extra special. We had the Mod-10 counter circuit using JK flip-flops with an LED display as well as a 7-segment display, so we get a little bit extra fun in there. If you want to come over here, lovely Emily has drawn up a beautiful circuit for us. Just want to kind of talk you guys through it here. We've got a couple different chips at play here. Primary one being our IC chip. What this basically does is it takes multiple JK flip-flop circuits, and instead of having to have a whole bunch of rat's nest going on with multiple wires jumping from spot to spot, using the IC chip, the integrated circuit, we can get all of these within one neat package. Really great for simplifying things and using that counting logic to create an output. Simple stuff, we've got our 5-volt power going in, some outputs that we have tied to LEDs for counting purposes. This way we can make sure as we're going through the circuit that power is actually being transferred from one chip to the other. Going to another integrated circuit, and we have our output and our 7-segment display. Obviously, resistors are key. Anytime you're working with an LED, you want to make sure you're not going to be sending too much juice into those LEDs and blowing something up. One thing that's unique to this circuit, though, and we'll really have it on display when we go over to the live and in-concert demonstration, is this AND chip. And what that does is it isolates two of the outputs coming from our integrated circuit. Those two outputs are I think that's A and C, or is that, yeah, B and D right there. Sorry, hard to see. B and D are isolated and then sent to an AND chip, which means they're being ANDed together. When you isolate B and D, you get a limit of 10 using binary numbers and counting. So what that does is it provides an automatic reset when the circuit gets to 10 on the display, being shown both through the LED and the 7-segment display. Nice for keeping track of counting and keeping those latches working in order. So that being said, we take the circuit from right here and transform it into something beautiful over here.
So
voila.
What we have here is our lovely circuit. It looks a little complicated at first, but we have our AND chip up here. Here is our 7493 chip, and that's going to be what we convert into binary. So over here, we have our binary counter LEDs. So as these are turning on, you can count in binary. There's 2 to the 0, 2 to the first, 2 to the second, and 2 to the third. And then over here, we have our BCD decoder chip. So what that's gonna do is it's gonna take the binary inputs that we have and convert them over here to our 7-segment display so you can see the actual number pop up. So let's start counting. So right now we're at 0, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then since we have our AND chip in here to have it reset at 10, goes right back to 0. However, say you're counting and oops, I counted too high. Well, we have a fancy push button over here that if you press it, just resets it right back at 0. So there we go, that's our circuit.
It wouldn't be a real circuit though without a little bit of troubleshooting.
Always.
Self-inflicted troubleshooting is always the best. So what we were having an issue with is our pulse switch that you see here. We needed the output of the AND to be tied into our resets on the IC 7493 chip. However, in a perfect world, that'd be great. When we hooked this up to our reset pulse switch, we weren't getting an automatic reset at 9, and we were able to get the manual, but obviously we need this circuit to stop at 9 and then reset. So having said that, we tried a few different methods, trying to get this together with the pulse switch, hooking it up directly to ground, or hooking it up to one of the other switches seen here on the board. Nothing was working, and it was a head scratcher, but luckily we used our troubleshooting steps. We were able to identify the problem, we verified it, which was that we were not able to get the automatic reset. This chip just kept trying to go all the way up. So eventually what we did is we determined that there was a mechanical error in the actual box itself. Circuitry was testing fine, so what we did is we did a little bit of a bypass, if you'll come over here. Coming out of the reset, we hopped over, tied this push button to 5 volts, but it's normally open. So that allows us to close that circuit and reset us back to 0. Nice little workaround. Doesn't look the neatest, but sometimes it's all about getting the job done. That being said, if you have anything else, thanks again for watching, and we'll see you guys next time.
One other thing is just calculations. 2 calculations we did was one of them was resistor R5, which is going to the 7-segment display. So we took 5 volts, divided it by 470, and sure enough, we got 10 milliamps. And then another one, we did power across the LEDs. We took 3.2 volts times by 8 milliamps, and that equals 26 milliwatts. And now that's our circuit.
Can't let Zach get out of here without getting the final word.
Hell
So
yeah.
hats off to Zach for the awesome camera work and the lovely calculations. Thanks again, guys.